let's start with how a logarithm is formed, basically. So we have, this is the quote-unquote equation for logarithms. We have the log itself, the base, and we have the input, equals an exponent. So we have log base input equals exponent. And this is the inverse. This is the inverse of an exponential function. And this can be swapped around to, like, basically what I would call the opposite equation, which would be the base to the power of the exponent equals the input. And you can see this in a simple equation like this. Log 2 8 equals 3. This aligns with this format, as I'm sure that you can all see. And using what we already have, we can apply each of these numbers right here to this. So that would make it so these are the same. So if 2 is our base, we have 2. And then we have 3 as our exponent. 3 equals 8. And this is a true equation because 2 cubed does equal 8. And if we wanted to get a little bit, like, in the case of a variable, let's just say that this was x, right? We do the same thing. 2 to the x equals 8. And x would equal 3. And this is basically how you would solve most of these types of problems. And there's a bunch of other problems that I'm going to go over right now that have certain, I guess, properties, quote unquote, that I'm going to mention. So, and there are a lot of things that I should mention. So, first of all, let's say that you get an equation like this. Now, you'll notice that this doesn't have anything. There's just nothing there. And in the case when there's nothing there, we automatically assume that it's a 10. And you'll see this in your calculators, because all the calculators are automatically programmed to base 10. So let's just say that this is invisible, right? Like let's just say that this 10 doesn't exist, even though we know it's a 10. The log of 1,000 is equal to 3. Because using our same logic, 10 would be the base, so that would be 10, times the exponent, 3 equals the input, which is 1,000. And again, this makes sense. This would be a true equation. And if you were to just solely input log of 10,000 on your calculator, it would give you 3, because we're automatically assuming that this is 10, and we're putting this in, and that would give you an answer of 3. And now we have questions like this. We have log 2, we have 1 over 16 equals x. I'll just say x. So this looks a little scary, but there's a very easy way to do this. So we all, well, maybe not we all know. I don't know. But 2 to the 4th power is 16. If you want to do any negative exponent, all you do is grab the same answer that you would get for the positive version of that and put it under 1. And what I mean by that is 2 to the 4th power is equal to 16. So 2 to the negative 4th power is equal to 1 over 16. All you do is take the answer that you would get from the positive version of the number and put it under 1 as a fraction. So now that we know that, we can apply this logic. 2 to what power equals 1 over 16. 2 to the negative 4 power is equal to 1 over 16. And also, let me mention this. So you know how I was talking about that base 10 stuff earlier? About like the log of 1,000 equals 3? Actually, okay, well, yeah, log 1,000 does equal 3. But let me do a better example. Let me just do log of 100 equals 2. That's what it equals. The log of 0.01 is equal to negative 2. And you can keep going down. The log of 0.001, that would be negative 3. The log of 0.0001 would be negative 4. You can keep going down. You can go up as well, like, say, the log of 1 million. If you really wanted to do that, the log of 1 million is equal to 6. So, like, basically, with all these numbers, like, if there's no base, and the base is 10, all you do is count the number of zeros, and you get the answer. You get 1, 2, 3, 4, 5, 6. And you get 6. And then with this, you have to start with the 0 before the decimal point. But you get 1, 2. And the answer is 2. Well, not 2, but negative 2. And basically, from what we've learned, we can apply this to literally like anything ever. Like log of 3 is 27 equals 3. 3 cubed equals 27. Log 7 to the 49 equals 2. We have 7 squared equals 49. But then there's also problems like this. Log to the 2 of x equals 0. So we have, which actually this is like the same thing, but not really. Because this time x isn't right here. X is right here. But using this, switching this to this format instead of the format that it's already in, which is this one, we can just use the same thing. But in this case, it would be 2 to the 0 power equals x. And x would be 1, because anything to the 0 power is 1. And then we have other problems like this. 2 to the x equals 0. Now this is undefined. This is undefined because no exponent that you can provide to a number will be equal to 0. Nothing. So, if for some reason the answer is 0, then it's undefined. We don't know what it is, we can't figure out what it is, and that's that. Let me also cover this. You'll have problems like this. Perhaps. I don't know. And that's log of 9 equals x. And sometimes the question will be, find the inverse of each function. And this would be the function of choice. To do this, first, we have to switch the variables. And what I mean by that is putting an x for y and putting a y for x. And now that we have this, we basically just kind of apply it to this. So this would be, excuse me, this would be 9, because we have a base right here, and then we have to the x power equals y. And that's how you would find the inverse for problems like that. And I'll do 2 more examples. So we have y equals the log of 6, x plus 1, and that would be what we have to solve. So again, we just switch the variables. So we have x equals the log of 6. We have y plus 1. And then we just switch it to this format again. So then we have the base of 6. We have 6. And then we have x as the exponent. So 6 to the x power. Then equals y plus 1. And then from here, all we do is subtract the 1. Which, to rewrite this in a better way, okay, well, first of all, we subtract the 1. So that would just be 6 to the x minus 1 equals y. And that would just be that. And then for our last example, we have y equals 5 to the 2x. And we have to find the inverse of that. So firstly, we have to switch the variables. So, what was I saying? Okay, so we have x equals 5 to the 2y. Hold on. Give me a second. Okay, the point is, we have this. The variables are switched, and now we need to make it into a log equation. So, because it's in this format right now, basically. Because x would be the input, and 5 is the base, and 2y is the exponent. So we need to switch it to this format right here. Which we can do, because we have log, 5 is the base, x is the input, and then 2y is the exponent. But we're not done yet. We still have to isolate y. Which that's just done by dividing 2 on both sides, and it's exactly what you think it is. It just looks like this. Log of 5 to the x divided by 2 is equal to y. So that's how you make inverse equations with logarithms. And now I'm about to go over what we learned in class today, kind of. I'm going to go over questions 2 and 3, so let's do it. It says, now explore the function h of x equals log 7x, which h of x is just a fancier way of saying y. And then it's to start by finding the inverse of this function, which the inverse of that would just be 7 to the x. So this is our regular function, and this is our inverse function. And I'm not going to lie, I did not prepare for this, right? Because on the next question, there's a big table that I probably should have wrote down, and I didn't, but whatever. The point is that there's a table where, there's like a side for x values and a side for y values. And there's 2 tables. One for the regular version, and one for the inverse version. And you just plug in numbers on the x just to see what you'll get for y, and then you just keep going. And then for the inverse, or to get the inverse, or whichever one you do first, like whichever one of these you want to do first, whatever, you just do the opposite of it on the other table. So let's just say, I don't know, for example, I get 1, 2. On the inverse, it would be 2, -1. I mean, this is -1. But yeah. So standard stuff, we already know this. It's easy. And if you're looking at your notes right now, that probably helps. But that's basically all that is. I think I got phlegm in my throat. I think I got phlegm in my throat. What the? But anyway, I think that's all I need to cover, and that's all I remember to cover. So I hope that this video helps, and if I missed anything, remember, this is a channel for the people. This is a channel for the people where they can ask questions, and I'll try to make a video explaining whatever it is they need to be explained. I made this channel for that. So if anyone has any questions regarding anything, please just leave a comment with your name and what you need help with, and I'll be glad to make a video on it. Please spread this with people so if they need help, they can receive help, because I want to help as many people as possible, because that's what that's what I want to do. But again, I just hope that these videos helps. Honestly, please leave any comments with possible improvements that I can make. But that's it. So peace.